show that the equation of the tangent CD is y minus x is equals to 3. So firstly, they just kind of gave us an unorthodox type of equation, or the way it's normally given in its non-standard form. So ideally what they want us to do is get the equation into x plus 3, right? So that's our normal standard linear equation form that we normally see it in, right? So firstly, if this is a tangent, what we do have is we have the coordinate c, and that is on that specific line CD. So that's good. We have one coordinate, and we also know that this Cn is a radius. So if we were to get the gradient of that radius, we will be able to get the gradient of that tangent since they are perpendicular together. So firstly, let's get the gradient of the radius. M of the radius is equals to y2 minus y1. And here we are subtracting 2 from 1. We can also use our coordinate b since it's on that same line. I think that's easier. Let's go ahead and use that. So it would be 2 minus 1 all over, and by the looks of it we can see that the radius itself is a negative or a decreasing function, so it will have a negative gradient. So this would be minus 1 minus 0 at the bottom, and then we get a gradient of minus 1 of the radius. And then therefore, since the gradient of the radius multiplied by the gradient of the tangent will equal to minus 1, therefore the gradient of the tangent is just 1. Right, so we have that, and we can just write our reason here. It equals to minus 1, and that is, well, the radius is perpendicular to the tangent. So once we have our gradient, we have a point, we can go sub this into our formula, y minus y1 equals to m into x minus x1. So again, our point is c, minus 1 and 2. So here we can go ahead and say y minus 2 is equals to 1 into x minus minus 1. So y is equals to x plus 1 plus 2, which is plus 3. But since they want it in the form of y minus x, so we can just take that on to the other side, where we get y minus x is equal to 3.